Today we're going to do percent composition by mass problems. These are not so much based on moles as they are based on actual grams. So you're going to start by looking at table T, where you should find this equation, or a version of this equation. If you look at your percent composition formula, it says the mass of the part equals the mass over the, percent equals mass of part over mass of whole times 100. We can actually rewrite this a little bit to be a little bit more specific for what we're doing. You could actually say the mass of an element or a component, which we're going to have to figure out based on, what the question says, divided by the mass of the entire compound, or the GFM for the whole compound, times 100 will give us the percent composition by mass for that component that we are looking for. So these are pretty straightforward questions. We want to know the percent composition of oxygen in copper nitrate. First thing we have to do is talk about what our component is. In this case, it's going to be oxygen. And we do have 6 oxygens, so we do need to keep that in mind. So we're going to say 6 times the mass of our oxygens, which is 15.9994. So each oxygen has that for a mass based on the periodic table. Gives us a mass of 95.9964, and technically this is in grams per mole. The units are going to end up canceling in our final calculation, but it is nice to have that there. Then we want to determine the GFM for the entire compound. So you're going to look up each individual atom and add them up. Your GFM for the whole compound should come up to be 187.5558. Our formula is going to be our component over GFM times 100. So we're going to plug in our 95.9964. Oh, sorry, this is in grams per mole as well. And that's in grams per mole, as is the 187.5558. Those are going to end up canceling since they're the same top and bottom. And we multiply that by 100 because percent means per 100. And what you should get for this is going to be 51.183%. You actually can keep a lot of these as far as sig figs go because you have a lot of significant figures in each number that you plugged in. For most of the questions that you'll be answering for percent composition, we do tend to round. So if you said 51.2, that's pretty darn good for this one. We have to do something called a hydrate in the next question. We saw one of these already once before. This little dot here does not mean to multiply. It just means we're adding water on. What a hydrate actually is we have this copper sulfate compound that is these physically associated waters. These can actually be driven off. We have actually dehydrated these in class. So if you heat this blue compound up, you may remember doing this, the waters will leave and you're left behind kind of a grayish colored compound. So we can actually calculate the percent by mass of water within that entire compound. So we have to look first at the mass of our component. So we have 5 waters, 5 hydrogen, or 5 times 2, so we have 10 hydrogens, and 5 times 1 is 5 oxygens. So we start by saying, okay, I got 10 hydrogens times 1.00794 grams per mole for each one, plus 5 oxygens times 15.9994 grams per mole for each one of those, giving me a GFM for water in this compound of 90.0764 grams per mole. Next, you're going to calculate your GFM for the whole compound, adding in the copper, the sulfur, the oxygen, and adding that 90 from the water as well. So this is going to give us a total of 249.685 grams per mole. For our formula, again, we're doing our component over our GFM times 100. Our component is 90.0764 grams per mole over 249.685 grams per mole times 100. And this one, again, you're going to need a lot of sig figs. We're going to go to 3 decimal places because when we were adding, that's kind of what we were limited to there. So you get 36.076%. And in this case, for a lot of these, again, we can kind of round them. So 36.1% was perfect. Oops. Shouldn't see those yet. Take a hot second and check out this problem. We want to know percent composition of each element in potassium chromate. Let's try first potassium, Cr, chromium, then oxygen. Fortunately, you kind of already saw those a little bit, but hopefully you were able to get the same thing. For potassium, you had to do 2 times 39.0983. Your gram per the mass for this whole thing is 194.1902. So for potassium, you're really doing 2 times 39.0983 divided by 194.1902 times 100. For chromium, you're doing 51.996 over 194.1902 times 100, and oxygen was 4 times 15.9994 over 194.1902 times 100. And again, I rounded these quite a bit. This one I really got 40.2680. This one I got 26.7758. These problems give you a ton of sig figs to work with, but usually rounding them down to 1 or 2 decimals is sufficient for what we're doing. So pause the video for a minute, try the next problem. So you should have gotten something that I actually calculated this out to be 34.582%. If you rounded that to 2 decimals, 34.59%. For your entire GFM, so you should have gotten 208.37612 grams per mole. For water, you have 8 hydrogens times 1.00794. 4 oxygens, so 4 times 15.9994. And that's going to go over your 208.37612. And you're multiplying that whole thing by 100. Last but not least, we have a challenge problem. If we have a 100 gram sample of propane, which is C3H8, how many grams of carbon do we expect that to have? So we can actually do a little wiggle room here using our, we can use mole calculations, and we could also say, hey, you know, I can figure out my percent by mass of carbon in this formula as well. So if you actually calculated the percent by mass of carbon from the formula, you'd say 3 times carbon's mass, which is 12.011, and that's going to, excuse me for just a second. That's going to give me 36.033 grams per mole for my mass of my component. To get my mass of my hydrogens, 00794. Mass coming from hydrogen of 8.06352 grams per mole. So to find my percent by mass for carbon, I'll just do 36.033 divided by 2 of these total together, which is 44.09652. I'm going to multiply that whole thing by 100. And this is actually telling me that my percent by mass in this compound for carbon is about 81.7%. I'm saying that out of 100 percent means out of 100. So this says that out of 100 grams, about 81 of those should be carbon. So that gives me about 81.7 grams of carbon in this compound.